Alright guys, hello. This video is over exponential growth and decay. I hope to make this video quick. Exponential growth and decay, let's get going. Alright, exponential growth occurs when a quantity is increasing by the same rate, r, for each time period t. Okay, so this is when something is growing at a very quick rate, alright? So an example of that is like insects, you know, as insects, the population of insects in an area growing really, really fast. You start out with a certain number of insects and then it just multiplies over time. Okay, so exponential growth is this formula here, y equals a times 1 plus r raised to the t. Now you need to write that formula down and write down what each of the variables stand for. Y represents the final amount. That would mean like the final number of insects after a given time period. A represents the original amount, how many insects were present at the very beginning. R represents the rate of growth, and what's important about that is we are always going to write the R as a decimal. So they're going to give us rate as a percentage, but we're going to take that percentage, move the decimal 2 places to the left, and write that as a decimal. Then T in our formula is going to represent how much time, the time period. So here we have our first question. The original value of a painting is $9,000, and the value increases by 7% each year. So the painting becomes worth more money as every year goes on. Write an exponential growth function to model this situation. So I'm going to use my formula here, y equals a times 1 plus r to the t, and plug in what I know. I'm looking for the final amount that the painting's worth. So I'm looking for y. A, my original amount. The original amount of my painting is $9,000. And then in parentheses, I always have 1 plus my rate. Well, my rate is 7%, but 7% as a decimal, move the decimal 2 places to the left, would be 0.07. So I write 1 plus 0.07 raised to the t. The t is the time, which in my case is 15. Now I'm going to pull up my calculator and I'm going to see what this equals. So first thing I'm going to do is I'm going to have 9,000, okay, times 1 plus 0.07, and then use my caret, raise that to the 15th. Press enter, and I see that my painting is going to be worth around $24,831.28. Okay, so that is an example of exponential growth. My painting value started at 9,000 and it grew over this 15-year time period. Okay, the next thing we're going to look at is exponential decay. This is the exact opposite of exponential growth. This is when something, a quantity, is decreasing by a constant rate over a time period. Now notice in this formula that the formula is exactly the same with one thing different. What's the one thing that's different? Exactly. In exponential decay, we have a subtraction sign, whereas exponential growth, we had a plus sign. So write this formula down. This is decay. When something is losing its, when the quantity is decreasing, you've got to subtract, as opposed to exponential growth. When something's growing, you add. So that's the only difference. The variables still stand for the exact same thing. So write that down. Let's look at an example. Here we're talking about the population of a town. The population is decreasing at a rate of 3% per year. In the year 2000, there were 1,700 people. Write an exponential decay function to model this situation. Okay, so I have my formula written. That's a great starting place. Now, it says in 2000, the initial population, so that's our A, the starting population was 1,700. So that's going to be where A is. And then I'm going to write 1 minus my rate as a decimal. 3% as a decimal is 0.03. And my time, well, we want to know what is the time in 2012. So that would be 12 years. Okay, let's figure out what this is going to give us. So in my calculator, I'm going to type 1,700 times 1 minus 0.03. And then I'm going to raise that to the 12th. And I'm going to see that my answer is 1,179.53. We can't have a 0.53%, so I'm going to say 1,180 would be the population of this town 12 years later. Okay? one more example. The number of employees at a certain company is 1,440 and is increasing at a rate of 1.5% per year. Write an exponential. Are we going to fill in that line with growth or decay? That's what I want you to figure out. We're going to write an exponential function to model the situation, and then find the number of employees in the company after 9 years. Okay, so keywords. What are the keywords I'm looking for here? It says that the number of employees is increasing. So is this going to be exponential growth or decay? Exactly. This is exponential growth. So the formula I'm going to use, y equals a times 1 plus r to the t instead of 1 minus r to the t. Okay, so that's my function. I'm going to plug in what I know. I know that the number of employees started at 1,440, so that's my a, my initial value. I have 1 plus my rate is 1.5%. 1.5 as a decimal is 0.015. Okay, and I'm going to raise that to the number of years, which is 9. Okay, so I'm going to figure that out. I'm type that in my calculator, and when I finish, I'm going to see that my answer is 1,646 employees. All right, guys, that is it. That is exponential growth and decay.